To examine length and mass, you'll do a few exercises. The first one, actually, we're still on Earth, and take a look at the Wikipedia page for the Statue of Liberty. The first exercise will ask you to look for some information about the Statue of Liberty from the Wikipedia page, in particular, her height. And her height is given in two different units. And what we're going to examine in this first exercise is comparing inches and centimeters. So first you'll go through getting the quantities from Wikipedia, and then you're going to do a conversion. So you're asked to convert her height in feet to inches, and then you're asked to convert her height in meters from the Wikipedia page to centimeters by multiplying by this conversion factor. And once you get your answers, it reviews that, in fact, these two quantities are equal because her height is the same. And then to divide the relationship between centimeters and inches, you just take the ratio. And so you have your answer for her height in centimeters and inches here, and you plug them into these formulas, and then you reduce the number. That's what's meant by numerical result of the division. And that tells you the relationship between centimeters and inches. So you should go through step by step the procedure. And the second exercise looks at a little bit deeper into space and reviews the sun and the earth and the distance between the sun and the earth. And the outermost part of our solar system is theoretically this puffy cloud of comets, which extends to enormous distances. In fact, 1.5 times 10 to the 13 kilometers, or 15 trillion kilometers, or 15 with 3, 6, 9, 12 zeros after it. And that is the distance of the outermost comets in the Oort cloud. So again, instead of these large abstract quantities in scientific notation, can we get better insight by looking at new units, inventing new units? So the distance between the Earth and the Sun is introduced, and this unit is called the astronomical unit. And you're asked to examine the extent of the Oort cloud in units of AU. And so once you take that ratio, you'll find that the outermost cloud of comets extends to this number, your result, in AU. And so instead of thinking about these large numbers of kilometers, we're going to have a distance in units of astronomical units. And the astronomical unit is the average distance between the Earth and the Sun. And the next exercise that you should go through step by step regards mass. And again, recalling that we have these new invented units that become very useful in our class and in astronomy of Earth masses and solar masses now become their own unit that correspond to the exact mass of Earth in kilograms and the exact mass of the Sun in kilograms. So we're asked to compare two objects in our sky. The moon is visible, the Pluto you would need a telescope for, and you're given that the moon in Earth masses is 0.012 Earth masses, and the mass of Pluto is 0.0024 Earth masses. So it asks you to examine their comparative masses, first judging which is more massive, and then the ratio, which tells you how many times more massive is the more massive one. And then the last exercise with measurement regards stepping even further into space and looking at not just our solar system, but beyond our solar system into the collection of stars that are held together by their own gravity called the Milky Way. And you're given the mass of the Milky Way here. It's about 2 times 10 to the 42 kilograms, a very abstract number. But if we divide that by the number of kilograms per solar mass, then we're going to find out how many multiples of the Sun's mass is our Milky Way. And that's basically a rough estimate of the number of stars that have masses like the Sun that comprise the Milky Way. And yes, it's definitely an approximation because there are many more stars that are less than the mass of the Sun and stars more massive than the Sun.